The 2020 National Electrical Code, referred to as the NEC, generally does not mandate retrofitting ground fault circuit interrupters, known as GFCIs, in existing multifamily residential buildings that predate the NEC GFCI requirements. For buildings erected in the 1970s, it's probable they were constructed before the NEC enforced GFCI installation in kitchens and bathrooms. NEC Article 210.8 stipulates that GFCIs must be installed in particular locations for new constructions and major renovations. These locations include bathrooms, kitchens, outdoor receptacles, garages, crawl spaces, unfinished basements, and wet bar sinks. However, NEC Article 90.3b provides an exception stating that existing installations are permitted to remain until replaced, removed, or abandoned. This suggests that existing electrical setups, including those without GFCIs, are grandfathered in, not requiring updates unless they are damaged or malfunctioning. It's important to note that local jurisdictions may have their own amendments to the NEC. These local codes could potentially require GFCI retrofitting in existing multifamily residential buildings. To ascertain the specific requirements in your area, it is advisable to consult with a local electrical inspector. This consultation will clarify whether any local amendments mandate GFCI upgrades. Even if not mandated by code, the installation of GFCIs in wet areas such as kitchens and bathrooms is highly recommended as a safety measure. GFCIs significantly enhance electrical safety by quickly interrupting the electrical circuit when a ground fault is detected, thereby reducing the risk of electrical shock. Understanding GFCI as a ground fault circuit interrupter, commonly referred to as a GFCI, is a crucial safety device designed to protect individuals from electrical shock. It operates by monitoring the balance of current flowing between the hot and neutral conductors in a circuit. Under normal circumstances, the current flowing through these conductors should be equal. However, when a ground fault occurs, such as when electricity flows through a person's body to the ground, this balance is disrupted. The GFCI detects this imbalance and rapidly cuts off power to the circuit, typically within a fraction of a second. This quick response significantly reduces the duration of the electrical shock, often preventing serious injury or even death. GFCI protection is particularly important in areas where water is present, such as bathrooms, kitchens, and outdoor locations, as water greatly increases the risk of electrical shock. The NEC specifies where GFCI protection is required to ensure safety. Firstly, bathrooms always require GFCI protection for all receptacles serving the countertop areas. This is due to the high risk of water contact with electrical appliances like hairdryers and curling irons. Secondly, kitchens mandate GFCI protection for receptacles serving countertop surfaces, recognizing the frequent use of electrical appliances near sinks and water sources. Thirdly, outdoor receptacles must have GFCI protection to mitigate the risks associated with wet conditions and accidental contact with the ground. Fourthly, garages require GFCI protection for receptacles to protect against potential hazards from power tools and damp environments. Fifthly, crawl spaces, due to their dampness and potential for contact with grounded surfaces, necessitate GFCI protection. Sixthly, unfinished basements, similarly prone to moisture and ground contact, need GFCI protection for receptacles. Seventhly, wet bar sinks, due to the combination of water and electrical appliances, require GFCI protection for their receptacles. Eighthly, boathouses also require GFCI protection because of their proximity to water. Ninthly, laundry areas are now included in the GFCI protection requirements. The NEC guidelines evolved to address new safety concerns and technological advancements. Therefore, regular updates and revisions are essential to staying informed about the latest requirements. Furthermore, local codes may impose additional requirements beyond those outlined in the NEC. Consulting local electrical inspectors is essential to ensure compliance with all applicable regulations. Installing GFCIs involves several steps to ensure proper functioning. Firstly, select a GFCI receptacle or circuit breaker that is compatible with the existing electrical system. Secondly, turn off the power to the circuit at the main breaker panel to avoid electrical shock. Thirdly, remove the existing receptacle or circuit breaker. Fourthly, connect the wires to the GFCI device according to the manufacturer's instructions, ensuring proper polarity. Fifthly, test the GFCI device after installation to confirm that it trips correctly when the test button is pressed. Understanding NEC Article 90.3. The NEC Article 90.3. B, which addresses existing installations, plays a crucial role in determining when electrical upgrades are necessary. This article states that existing electrical installations are permitted to remain in service unless they are replaced, removed, or abandoned. This provision recognizes that requiring immediate upgrades to meet the latest code requirements for all existing installations would be impractical and economically infeasible. However, when an existing electrical system is modified or expanded, the new work must comply with the current NEC requirements. For example, if a homeowner adds a new receptacle to a bathroom circuit, the new receptacle must be GFCI protected, even if the existing receptacles and the circuit are not. Similarly, if an existing circuit is extended to serve a new area, the extension must comply with current code requirements, including GFCI protection where required. In addition to modifications and expansions, replacements also trigger the need for code compliance. If an existing receptacle or circuit breaker fails and needs to be replaced, the replacement must meet the current NEC requirements. This means that if the replaced device is located in an area where GFCI protection is now required, a GFCI receptacle or circuit breaker must be installed. The NEC also addresses situations where an existing electrical system is deemed unsafe. If an electrical inspector identifies a hazardous condition such as damaged wiring or overloaded circuits, the inspector can require the homeowner to correct the problem, even if the installation was compliant with the code at the time it was installed. Understanding local amendments. Local jurisdictions, such as cities, counties, and states, have the authority to adopt and amend the NEC to suit their specific needs and priorities. These local amendments can be more stringent than the NEC, requiring additional safety measures or addressing unique local conditions. For example, some jurisdictions may require arc fault circuit interrupters, known as FSIs, in more locations than the NEC mandates. FSIs are designed to protect against electrical fires caused by arcing faults, which are dangerous electrical discharges that can occur in damaged or worn wiring. Other jurisdictions may have specific requirements for the installation of smoke detectors or carbon monoxide detectors in residential buildings. These requirements may go beyond the NEC provisions to address local concerns about fire safety or carbon monoxide poisoning. It is essential to consult with the local electrical inspector to determine whether any local amendments apply to your project. The electrical inspector can provide guidance on complying with these amendments and ensure that your electrical installation meets all applicable requirements. Understanding safety recommendations, even when not mandated by code, installing GFCIs in wet areas is a prudent safety measure. GFCIs provide a significant level of protection against electrical shock, especially in locations where water is present. The cost of installing GFCIs is relatively low compared to the potential consequences of an electrical shock injury. Installing GFCIs is a straightforward process that can be done by a qualified electrician or a homeowner with electrical experience. In addition to installing GFCIs, it is also important to practice other electrical safety measures. These measures include avoiding the use of electrical appliances near water, keeping electrical cords in good condition, and avoiding overloading electrical outlets. Regularly inspecting electrical cords and appliances for damage is essential to prevent electrical hazards. Replacing damaged cords and repairing faulty appliances promptly can significantly reduce the risk of electrical shock and fire. Avoiding the use of extension cords as a permanent wiring solution is also important. Extension cords are intended for temporary use only and can become overloaded or damaged if used continuously. Overloading electrical outlets can cause the wires to overheat and potentially start a fire. Using power strips with built-in circuit breakers can help prevent overloading and protect against electrical hazards. By following these safety recommendations, you can significantly reduce the risk of electrical shock and fire in your home.